Next, let's talk about standard enthalpy change of neutralization. As I said before, standard, that means the reaction is carried out under standard conditions. There is a symbol phi in the superscript, okay? Delta means change, N stands for neutralization. When 1 mole of dilute nitric acid reacts with 1 mole of sodium hydroxide, 1 mole of water is produced. At the same time, underline, 57.3 kilojoule of heat is released. You should remember, all neutralizations reactions are exothermic. So 57.3 kilojoule of heat is released. The enthalpy change of neutralization measured under standard conditions is known as standard enthalpy change of neutralization. It is denoted by this symbol. Here, let's look at the thermochemical equation, okay, for the reaction. We have nitric acid in aqueous. Now bear in mind, in writing thermochemical equations, states are important. Aqueous, and then react with NaOH, aqueous state, to form salt. NaNO3, it is a soluble salt, therefore its state is also aqueous, and water, liquid. Because I'm now writing the thermochemical equation, so you need to put the delta H beside the equation. Delta H N phi is equal to negative. Do you remember what is the meaning of negative? Negative, that means energy is released, heat is released. That means the reaction is exothermic. Negative 57.3 kilojoule per mole. Now, let's focus on per mole. What is the meaning of per mole? Per mole of what? Standard enthalpy change of neutralization is the enthalpy change. Bear in mind, every time in writing the definition, you use this format. Is the enthalpy change when, but you must highlight this one, 1 mole of water is produced from neutralization between an acid and an alkali under standard conditions. Why do I need to end up the definition by saying that under standard condition? Because of this term, standard. Standard. If you see that the term has this word standard, then you must end up your definition by saying under standard conditions. Okay? Now, in Form 4, you have already learned neutralization. It is the reaction between an acid and an alkali to form salt and water only. Therefore, the definition, refer to the definition, standard enthalpy change of neutralization is the enthalpy change when 1 mole of water, bear in mind, when 1 mole of water is produced. Now, in other words, look at these equations again. In this equation, when 1 mole of water is formed, 57.3 kilojoule of energy is released. Understand? During neutralization, hydrogen ions from the acid react with hydroxide ions from the alkali to form water molecules. This is the Arne equation for neutralization. Hydrogen ion react with hydroxide ion from alkali to form water. For 1 mole of water produced, 57.3 kilojoule of energy, of heat energy, is released. As neutralization is an exothermic reaction, so let's look at its enthalpy level diagram. Again, please bear in mind, label the y-axis. The y-axis is enthalpy. Because the reaction is exothermic, therefore the delta H is pointing downwards. Okay? Here are the reactants, the enthalpy of hydrogen ion and hydroxide ion. 57.3 kilojoule of energy is released to form 1 mole of water. Bear in mind, states are very, very, very important. Now, let's turn to the next page. Please look at this table. Table below, List the standard enthalpy changes of neutralization for different combinations of acids and alkalis. If the acid is nitric acid, the alkali is KOH, heat of neutralization is 57.3 negative. If I change the alkali to NaOH, same standard enthalpy of neutralization, same value. H2SO4, change the acid to H2SO4, is also a strong acid, neutralized with a strong alkali. We have the same value, okay, for the heat, standard heat of neutralization. HCl, NaOH, strong acid, titrate with strong base. The same value for the standard heat of neutralization, okay, standard enthalpy of neutralization. However, if we change the acid to weak acid, the standard enthalpy changes of neutralization is smaller. Now, listen, be careful. Now, in comparing negative value, don't simply say that this number is smaller. Now, because in usual mathematics concept, 0 is here, okay? If we have negative 55.2 here and then negative 57.3, that means negative 57.3 is smaller than negative 55.2. So if you tell me 55.2 is smaller than negative 57.3, is wrong, because usual mathematics sense, this number should be bigger. Now, however, in comparison, we don't want the negative sign. We only want the number, to compare the number. So, how to interpret this idea clearly? We need to use this term, the magnitude. The magnitude. The magnitude. Magnitude means 數量, okay? The magnitude of the standard enthalpy change of neutralization between ethanoic acid and NaOH is smaller than that between HCl and NaOH. Is there any problem about this presentation? You need to add this term, magnitude, 數量, because we don't want to compare the negative sign, because all have negative sign. We don't want, we only want to compare the number. So in writing English, please add the magnitude of the standard enthalpy change of neutralization between ethanoic acid and NaOH is smaller than that between HCl and NaOH. We need to explain why the magnitude of the standard enthalpy change of neutralization in this situation is smaller. Okay? And then here, let's look at the last one. HCl. HCl is a strong acid. Ammonia is a weak base. Let's look at the standard enthalpy change of neutralization. Again, the magnitude is smaller. Magnitude, we skip the negative sign, only talk about the number. The magnitude of the standard enthalpy change of neutralization between HCl and ammonia is smaller than this one, okay? Than that between HCl and NaOH. Again, we need to explain why. Let's look at the paragraph below. All neutralization reactions between strong acid, underline strong acid, and strong alkali are reactions between hydrogen ions and hydroxide ions. Thus, they release more or less the same amount of energy. Release the same amount of energy. Okay? That means if we have strong acid neutralized with strong base, then you can predict the standard enthalpy change of neutralization. It should be approximately equal to negative 57.3 kilojoule per mole of water form. Understand? However, let's look at the last paragraph. Very important. Less heat will be released if, underline, if a weak acid or a weak alkali is used. Do you know why? Now, based on your Form 4 knowledge, do you remember what is the meaning of a weak acid or a weak alkali? A weak acid is an acid. A weak acid is an acid that is incompletely ionized in water to form hydrogen ions. Do you remember this definition? You need to bear in mind. For example, ethanoic acid. Ethanoic acid, as you know, that it is a weak acid. It is incompletely ionized in water to form hydrogen ions. Incompletely ionized, therefore we need to use a reversible sign. This is ethanoic acid. The name of the salt is called ethanoate. Ethanoic ion, okay? Incompletely ionized, okay? This is because some energy has to be supplied for complete ionization of the weak acid or weak alkali. Now, in other words, originally, ethanoic acid is incompletely ionized to give hydrogen ion and ethanoic ion. However, during the neutralization, some energy is needed for complete ionizations of weak acid. That means until all ethanoic acid is neutralized. Where is the energy comes from? Comes from the heat of neutralization. So the value, the final heat of neutralization is with a smaller magnitude. Do you understand? With a smaller magnitude.